NCERT 12th Standard Physics, Chapter 3.3, Electric Currents in Conductors. So, in this topic, we are going to deal with electric currents in conductors. Okay. An electric charge will experience a force if an electric field is applied, and if it is free to move, it will thus move, contributing to a current. That means we have electric charge and we are applying electric field, and if the charges are free electron means it is not attached with the atomic structure, it is free electrons. Now in a material, if the electric charge is applied with the electric field, okay, then it experiences a force because it is a free charge. Okay. Now, in nature, if you see, free charged particles do exist, like in upper strata of atmosphere called the ionosphere. So, not only in nature also we have free charges. If you see this is here, in the ionosphere we have ions. So we have free charges that will start conducting. Okay. Therefore, in nature, free charged particles do exist, like in upper strata of atmosphere called the ionosphere. Okay. Now, in some materials, if you see, the electrons will still be bound and they will not accelerate even if the electric field is applied. So if you see, there are some materials, there are some special materials in which even if you apply electric field, the particles are not accelerated. Okay. So therefore, in such materials, we cannot expect any current. Okay. But in the case of metals is a good conductor of electricity. Some of the electrons are practically free to move within the bulk material. That is, if you have a bulk material, metals have free electrons. Within this volume of that material, these free electrons are allowed to move, causing a current. These materials, generally called conductors, develop electric currents in them when an electric field is applied. That means when this will have some distance between two ends, and if I apply a voltage, this voltage, so you know electric field is unit is volts per meter, voltage divided by length. So electric charge starts moving, and therefore you will be seeing a current. Okay. Now, if we consider solid conductors, then of course the atoms are tightly bound to each other, so that the current is carried out by the negatively charged electrons. That is, in solid conductors, if you see, this electron, the current is due to, I is due to electrons only, free electrons. If I say electron, it is due to free electrons. There are, however, other type of conductors like electrolytic solutions. Suppose if you have by doing electrolysis, that is, you have a positive plate, negative plate, and in between you will be giving supply. So there will be an electric field as well as ions, positive ions and negative ions. So there are, however, other types of conductors like electrolytic solutions. In this you will be having an electrolyte. Okay. Anions move to anions, and it produces anions and cations. So electrolytic solutions where positive and negative charges both can move. So we said in solid conductors only electrons are allowed to move, whereas in electric solutions both positive charge as well as negative charge will move in the electrolytic solutions. But in this chapter we are going to deal with solid conductors, that is solid metallic conductors, in which we have free electrons and the free electrons will start moving. Okay, next. Now we are going to discuss what happens when the electric field is not applied to the conductor. Suppose this is a conductor, okay. You have not given any electric field. That means the voltage across the conductor, this value is 0, V equal to 0, and you have some distance here. So in this case, there is no electric field. So we said already in conductors there are free electrons. So what happens to that free electrons? Okay, the electrons will be moving due to thermal motion. So the electrons will be moving due to thermal motion. Okay, due to thermal motion it will move randomly, which they collide with the fixed ions. So some fixed ions will be there, so they will collide with those ions. An electron colliding with an ion emerges with the same speed as before the collision. So the electron is here, it is hitting a ion. So after hitting, this velocity and the bounce back velocity or the return velocity will be same. Before and after collision, the velocity is same. However, the direction of its velocity after the collision is completely random. So that means after collision, this negative charge, it can move anywhere. It can go this way. So we cannot predict the direction of movement of charges. So it is random. So all this happens because of when we apply no electric field. So this movement is due to thermal conduction, because of thermal motion. And it will start hitting the fixed ions, and the initial before collision and after collision the speed is same, and the direction we cannot predict. It can move in any direction. Okay, so thus on the average we can say the number of electrons traveling in any direction will be equal to the number of electrons traveling in the opposite direction. So if you consider, suppose 100 electrons are there, some 50 electrons are moving in this direction, then another 50 electrons are moving in the opposite direction. This is the net analysis, overall average value. So that means number of electrons moving in the positive direction is equal to number of electrons moving in the negative direction. So there will be no net electric current. Okay, now we will see a conductor. This is a conductor, and we are applying an electric field. What happens, suppose this is an insulated dielectric, here also dielectric. This dielectric is charged with plus Q, and this dielectric is charged with minus Q. Okay, so what happens is the plus Q tries to neutralize the minus Q. So once it neutralizes, so that is, you have a dielectric, you are making it positive Q, and here it is minus Q. So this positive Q try to neutralize with the minus Q. Okay, now this what happens, and it neutralizes, and there is no current afterwards. Suppose you want a steady state current, what you have to do is you have to connect it to a battery or a cell. In that case, if you connect, a voltage is applied, you have a distance, that means an electric field is established. That means already we said this plus Q has been neutralized with a minus Q, and thereafter whatever additional potential you are giving between this end and this end, there exists an electric field, and the current I starts flowing through the conductor. Okay, so the main point is the neutralization of charges. So neutralization of charges happens before we apply the voltage. That means this plus Q neutralizes with minus Q. Okay, now after neutralizing, if you give an voltage, we see a steady flow of charges within this material. Therefore it creates a current, and this happens because of if we connect a cell, or battery. Batteries is nothing but series of cells. If you connect, so there will be a current flowing through the material. So this is the basics of electric currents in semiconductors. So when you apply no electric field, voltage is not applied. Then because of thermal motion, an agitation appears within the conductor. Before and after collision, the electrons speed will be same, whereas the direction is random, and the number of electrons moving in the positive direction is equal to number of electrons moving in the negative direction. And if you make a conductor this positive charge and this negative charge, this positive charge tries to neutralize with the negative charge, and once it has been neutralized, if you apply a voltage, because of this distance, an electric field is created and therefore current flows in the circuit. So now we have seen what happens when an electron is bounded with atomic structure. Nothing will happen. You must have free electrons, then only there will be a current flow. And we have seen about ionosphere. Ionosphere is this is Earth's surface, and you see ionosphere. There you can see ions, and we have free electric charges, and this will start conducting. So there are some materials which will not accelerate any electrons. Accelerate means only when electrons move, current is there, but there are materials. In metals we have surplus electrons, free electrons. So we have two types of conductors. One is solid conductors, where the electron conduction or current is due to only electrons, whereas in electrolytic solution the current is due to both positive charge and negative charge. So in a nutshell, we have seen all the basics charge flow in a conductor when a field is applied, when the field is not applied. So that's all about electric currents in conductors. So we are focusing mainly on conductors. Thanks for watching. Nandri.